Hello, my name is Joe Vasta, and today we'll discuss a standard pair of dice. We have two dice, green and orange. Note the opposite sides on each die add up to 7. How many different outcomes are there when rolling a pair of dice? Well, there's 36 outcomes. Let's list the outcomes. We can have the green die land on 1 and the orange die land on 1. So, if you're playing a game like Monopoly, you would move your piece 2 spots. The sum is 2. There's another outcome where the green die lands on 2 and the orange die lands on 1. The sum is 3. The green die can land on 1 and the orange die can land on 2. The sum is 3. There are 2 ways to get sum 3. There are 3 ways to get the sum of 4. Green 3, orange 1, green 2, orange 2, and green 1, orange 3. Let's put up the rest of the outcomes. Now we'll put the sum distributions along the bottom of this diagram. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. For example, the sum of 9 comes up 4 times. The sum that comes up the most is 7. And you probably experience that when playing a game. Whereas the sum 12 doesn't come up that often. Notice there are 6 doubles in our diagram. Using natural numbers only, can you renumber the faces of a pair of 6-sided dice so that their sums have the same distribution as the sums from a standard pair of dice? Natural numbers are 1, 2, 3, 4, 5, 6, 7, etc. You can use numbers that are greater than 6, but you don't want to use numbers that are greater than 11 because you want the sum distribution from the previous slide. You can also repeat numbers. For instance, maybe the red die has 1, 3, 3, 4, 4, 5. And both dice will not be identical. Each will have a different number scheme. You might want to pause the video to see if you can come up with the numbers that will solve this problem. Here is the answer. These dice are called the Sicherman Dice, named after Colonel Sicherman, who came up with this answer. The answer is unique, which means we cannot find a different solution. The red die has 1 1, 2 2s, 2 3s, and 1 4. The opposite sides on the red die add up to 5. The blue die has 1, 3, 4, 5, 6, and 8. The opposite sides on the blue die add up to 9. Let's look at the sum distribution. There is one way to get sum 2, red 1, blue 1. There are 2 ways to get sum 3, red 2, blue 1, and red 2, blue 1. There are 3 ways to get sum 4, red 3, blue 1, red 3, blue 1, and red 1, blue 3. Let's put up the rest of the outcomes. Now we'll put the sum distributions along the bottom of our diagram. This is the same distribution we saw with 2 standard dice. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. You could pretty much play Monopoly with these Sicherman dice. There's one difference. You'll only see 4 doubles in our outcome instead of 6. If you hate algebra, then you might want to end this video now. Otherwise, you've been warned. What you see is the green standard die and its generating function. The generating function tells you about the green die and has 6 terms. For each term, there is a coefficient and an exponent. The exponent represents the number you see on the die, and the coefficient tells you how many sides of the die the number appears on. The 1 appears one time, the 2 appears one time, the 3 appears one time, etc. Here's the orange standard die with its generating function. Both generating functions are identical because both dice are standard dice. We multiply our generating functions together to get a new generating function which has 11 terms. For each term, the exponent represents a sum, and the coefficient tells you how many ways you can get that sum by rolling the dice. Notice the coefficients. 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1. This is the sum distribution for two standard dice. This polynomial is the generating function for two standard dice, and it is also the generating function for the Sicherman dice. Let's do some algebra to verify this. We'll put the expression back into factored form. In the next few steps, the algebra will happen within the brackets. We factor an x out of the first three terms and an x to the fourth out of the last three terms. We went from 6 terms to 2 terms. Each of those 2 terms has a common factor of 1 plus x squared. So I factor it out front. I'll factor an x out of the second factor. We'll put it out front. The third factor is the sum of 2 cubes. I'll factor that. Now I have 4 factors within the brackets. I'll square each of those factors. I'll do this by writing 2 copies of each factor. We have just factored the generating function over the real numbers. I'm going to partition these factors into 2 groups, the red group and the blue group. When I multiply the red factors together, I get the generating function for the red Sicherman die. The 1 appears 1 time, the 2 appears 2 times, the 3 appears 2 times, and the 4 appears 1 time. When I multiply the blue factors together, I get the generating function for the blue Sicherman die. The 1 appears 1 time, the 3 appears 1 time, the 4 appears 1 time, the 5 appears 1 time, the 6 appears 1 time, and the 8 appears 1 time. And that's one way to discover the Sicherman dice. There are other ways. Also, you can verify that the solution is unique by investigating the factored version of the generating function. This concludes my video about the famous Sicherman dice. I hope you enjoyed it. Have a good day.